case, I only consider one side for the failure. So this is based on, when you see this, this is over here based on single shear. Okay. If you decide to do a double shear, you also have to consider this area over here. Double shear means left and right, right? So under double shear, consideration, right? The Q will be equal to 386 times 10 to the power minus 6 times 2, right? So 386. So it's equal to 772 times 10 to the power minus 6. And then when you write this formula, right, you will have 35 times 10 to the power 3 multiplied by 772 times 10 to the power minus 6 divide by 0.270236 times 10 to the power minus 3. Now this is equal to 2F divided by 0.25. The 2F over here, the 2 down here, is because of double shear. Okay. So 772 power. So this F will also be equal to 12.498 times 10 to the power 3 Newton. Okay. You decide what you want it to be. Okay. Now, I've not tried this before, but I'm going to try. Usually when I say that, I get myself into trouble. Can we consider the centerpiece? You get what I mean? I don't know, man, but I'm going to try. Okay, I'm, as I said, I've not done it before. Okay, but I'm going to try. So if I do that, it'll be a double shear configuration. Okay. Thinking about first principle, the geometric centroid is based on is based on geometry, right? So it should work. Okay, it should work. Okay. So the only way I know it should work is the Q. By the time we finish calculate the Q, it has to be 772 times 10 to the power minus 6. Yeah, it has to be, if it's true, it has to be 776 times 10 to the power of minus 6 meter cube. Okay, let's try. Okay. Yeah, this is where I get myself into trouble. And this is where students get confused. Okay, but I'm going to try. So we have this, right? Now we have to be very, very careful with geometry down here. So the Y bar is equal to 0.18676. Okay. So I'm going to consider using the center web. Okay. So if I consider the center web, the failure will occur on the left. The failure also will occur, or wrong color, will also occur on the right. So I know that my Q for the Y, the width is also 0.025. The depth I know, which is given as 0.35. the y bar is equal to 0.35 plus by 0.1. So I've taken the whole thing, right? Minus by 0.18676. Okay. So this gets my bottom, then minus by 0.35 divided by 2. Okay. So 0.35 plus by 0.1 minus by 0.18676 minus by 0.35 divided by 2 times by 0.35 times by 0.025 is equal to 7.721 or 772.1 times 10 to the power minus 6 meter cube. Let me check again. The width is 0.025. The depth is 0.035. This 0.35 plus 1 will get me from here to here, right? And then minus by 0.35 divided by 2. So let me do it again. 0.35 plus by 0.1 minus by 0.18676 minus by 0.35 divided by 2 times by 0.35 times by 0.025 is equal to 772.1. Okay. I'm nervous now. So what was it before? 772. 772. Close enough. Are we clear? All right. So whether you take from the left and right, okay, or when you take from here, from the consider the center web, it is the same. Okay. So again, another way of checking, another way of doing a problem. Okay. Any question? Okay. Okay. Then the next one, Michael. Question number 3 from which homework, Michael? Can you
Sorry,
type down?
still 7.
Hey, still 7.
Yeah, I meant to say 3 earlier. I'm sorry. I'm so sorry.
7. So this question, you want to do this question, right? Or no?
Yeah.
Okay. Next is question number 3. Right. So question number 3, the concept is very similar to not this one, but to the previous one. Okay. The concept is, so again, we have to design the shear flow. Okay. Okay. So this is homework 07, question 3. So this is what we have. So we are given that the 4 boards are all nailed together. Okay. We know that each nail could support 100 pounds. We are going to calculate the spacing for S prime and S if the beam is subjected to a shear of V equal to 700 pounds. Okay. So the formula we're going to use is Q is equal to VQ over I. and this is equal to F over S. Okay. So now by looking at this, we know that F 100 pounds, right? And we know that V 700 pounds. I'm going to call this my X. And then this is our Y. And I'm going to proceed this into our Z. Okay. So from here, we know that, okay, you have to find Y bar is 3.3548. From top. And then we also know that IZZ is equal to 337.43. Again, in a problem like this, designing shear flow, very important. Okay, so now I'm going to sketch, and I'm going to design our shear flow. I'm going to stop at the geometric centroid. And then we have our fastener. Then we have the other fastener. Then I'm going to design our shear flow. This is our shear flow, or however you want to draw it. Okay, does not matter. Okay. So if we are going to look at our, hey, sorry, computer crash. Go on. It's back. You can hear me, right? Nothing. Yeah, my computer just did something funny. So again, so this is our member number 1, member number 2, member number 3, member number 4. Right? Failure will occur here. Failure will occur here, and failure will occur here. Okay. So let's consider S. Right? Which is distributed on the horizontal nail, right? So the area to first movement area to consider is this area. You ask me, Eugene, why you don't consider the member number 2? because member number 1 is independent of member number 2. They have their own terminus. Okay, so you don't need to consider both. So once you have that, okay, so Q with 1, step 3,